Okay, today we're going to look at lesson 15, and your I can statement or learning objective is I can analyze graphs and find zeros of polynomials. So we're still working with polynomials. We're going to do some different types of problems today, talk about a couple different things, and go from there. So this is a little bit different than what I normally do. Normally I write the notes as we go, but I'm doing it different today. I've got all the notes written. I'm going to talk through them piece by piece, and then we're going to switch over to the examples. And then I am going to need to show you some things on the Desmos calculator, so I'm having to record a little bit differently than I normally do. Normally I write some things and pause and write some more and go back and forth, but it's not going to be as easy today, so forgive me if the video is not as smooth as it normally is, okay? So I do recommend that you write some of these things down, pause the video every now and then and write some things down. Try the examples, do what you need to do. Remember, I'm going faster in the video than I would be in person, so feel free to pause and watch it at your own pace as you work through the Math Excel work. But we'll go ahead and get started. So first, today we're talking about zeros, and we know, we've made this connection before, but real zeros refer to the x-intercepts of the graph. So that's what we're going to talk about today. So zeros, or real zeros, are x-intercepts. So if you graph the function in the coordinate plane, the zeros appear as x-intercepts. We can find those zeros a couple different ways. You can find them algebraically, and you do that by factoring the polynomial, setting the factors equal to 0, and then solving. Okay, we're going to do some of that today. You can also find them graphically, and to do that, you just graph the polynomial on the calculator and find those x-intercepts. Okay, and we're going to do some of that too. All right. This would be a great time to pause the video and write this information down. All right, moving right along. You can analyze graphs by looking at a few different aspects. You can look at zeros, you can look at the degree, the leading coefficient, the leading term, in behavior, etc. So all that stuff that we've talked about the past couple days, you can use to analyze the graph of a polynomial. Okay, and then today we're going to look at how to include the zeros in that information. All right, the last thing that we're going to talk about before we do some examples is multiplicity. So multiplicity refers to how many times that zero or that x-intercept occurs. All right, we've said before you can have a repeated x-intercept or a repeated zero or repeated solution. Like when we had quadratics, your two solutions could have been x equals 5 and x equals 5. Sometimes it works out that way. So the multiplicity just tells us how many times that zero occurs. If it's an odd multiplicity, so an exponent of 1, 3, 5, 7, 9, etc., that means that the graph goes through that x-intercept or through that zero. And here's a good example. Y equals x to the first, all right, that's a linear equation. The line goes through the the origin. That x-intercept is at 0, so that multiplicity of 1 is odd. It goes through the point. Even is when you have a multiplicity or exponent of 2, 4, 6, 8, 10, etc. And that means that the graph bounces back at that point. So it doesn't go through it, it bounces back. It turns around and goes back the same direction. Okay, so here's an example. We have y equals x squared. X squared, we know that's a quadratic. That's an exponent of 2. And so that origin or that x-intercept at 0, the graph or the line doesn't go through it, it bounces back up and curves, okay? So odd goes through, even bounces. All right, here's another way to look at multiplicity. Sometimes you're given the factors of the polynomial, and then you have to figure out the multiplicity from there. And you can see them a couple different ways. Here's one example. You have x plus 1 all raised to the 4th and x minus 2 to an understood 1. So that exponent of 4 means that this factor or this zero has a multiplicity of 4. So the zero would be negative 1 because it's the opposite of that. And so it has a multiplicity of 4. That means that that zero or that intercept is repeated 4 times. And since this one's even, that means that the line would bounce at that 0. Okay, x minus 2 has a multiplicity of 1. It's odd. That means the line would go through that x-intercept like this. Here's another way you could see them. Here we have x plus 1 times x plus 1 times x plus 1 times x plus 8. So your repeated 0 is x plus 1. It's repeated 3 times, so it has a multiplicity of 3. So that's odd. That means that the line would go through that intercept. Okay? And then we have x plus 8. That's just repeated once. It has a multiplicity of 1, and so the line would go through that point as well. So we're going to look at a couple different examples where you're going to have to identify the multiplicity and the zeros. And so you'll see how to do that when I work them out, so don't stress. But you need to know what multiplicity is referring to when we say that. Okay, so now we're going to switch gears a little bit. We're going to look at some example problems from Math Excel, and I'm going to show you how to work through those. If you haven't, now would be a great time to pause the video or rewind the video and take these notes down so you have them to use during your Math Excel work. Okay, sorry about that. Now we are going to work through some examples. These problems align directly with your problems in Math Excel, so you can use these as very, very similar examples. And it should help you as you work through Math Excel on your own. Okay, so number 1, we find zeros of the function. And so I mentioned that we could do this algebraically, okay, and so that's what we're doing here. So it's already factored, so we just set the factors equal to 0 and solve. Now, we did that with quadratics, and we saw a pattern. So we'll see if you notice it again. So we do x plus 1 equals 0, x minus 4 equals 0, and x minus 5 equals 0. Okay, so you solve those. So minus 1, so we get x equals negative 1. Add 4 and get x equals 4. Add 5 and get x equals 5. So our zeros are the opposite of what it looked like in the factors. So our zeros are negative 1, 4, and 5. Okay, and so that's a shortcut. If you don't want to write out each one equal to 0 and solve, just know they're the opposite of what they appear in the factors. Okay, so number 2, we're going to do the same thing, but we're also choosing the graph that matches. Okay, so our factors are going to, or our zeros are negative 3, 4, and 6. Now, to pick the graph, you can do it a couple different ways. You can type this in your calculator just as it is, or you can use what you know about the degree and the end behavior to narrow out some options and pick from there. You can look for the x-intercepts on the graph and then go from there. You have a few different options. So I personally think that it's good for you to be able to look and look at the polynomial and pick the graph from there. But if that's difficult for you, just go ahead and graph it, okay? So we have x times x times x, and so that would give us x cubed. That means that we have a positive coefficient and an odd exponent or odd degree. So that means it's going to look something like this. Our ends are going to be opposite and we're going to be going up. Okay, so I can narrow out B and D pretty easily. Now, let me look for my x-intercepts. I have a negative one and 2 positive. So over here I have a negative and 2 positive. Over here I have 2 negatives and 1 positive. So the negative 3, 4, and 6, that would match A. So that's the one I'm going to choose. Okay? All right, number 3, for this function, use the leading term test and knowledge of y-intercepts to match the function with one of the graphs below. So again, you are welcome to type this in your calculator and pick out the graph that matches, but I'm going to use our analyzing skills to pick the correct one. So our coefficient is positive, and we have an even exponent. So that means that it's going to look something like this. That narrows out A and D. And we know it's going up because it's positive, so that makes it option B. Okay. Another thing we could look at is the y-intercept. That y-intercept is negative 3. So that leaves us with only this one. This is the only one that has a y-intercept of -3. All right, so number 4 is very similar. We're going to, again, you can graph it if you want to, and 5 is also very similar. You can graph the polynomial and then just pick out the graph that matches, or you can analyze it. I'm going to analyze it just again because I think those are important skills. So it's positive and odd, so that means opposite directions, and we're going up. So I'm going to eliminate all of the ones that do not have ends in opposite directions. Okay? And it's positive, so we're going up. So that one's going down, and that one's going down. And then our y-intercept is -4. And so this F does match there. Okay? And like I said, number 5 is very, very similar. So I'm not going to go over that one because you're going to do the same thing that you did on number 4. And this time we have an even exponent, so we know our ends are going the same, and it's positive. So that can narrow out. Oh yeah, that's because that's negative. Okay, so that leaves us with these two options. Then you can do by the y-intercept, so that -13. This one's going by 5, so -5, -10, -15. -5, -10. So which one looks like it's probably at 13? D. And I said I wasn't going to go over that one, but I did anyway. So that's fine. All right. Now, number 6, I'm not going to go over that one for real this time because you can use those same skills that I was just talking about, or you can type that in the calculator. All right. Number 7. You can type it in the calculator if you want to, or we can analyze it. I'm going to analyze it just to show you how it works. So x, 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 and x, so that's x to the 4th, and it's positive. So that means our ends are going the same direction, okay? And so that can help us. And then we can also pick out the zeros. So we have 0, 1, -1, and 6. So it has to go through the origin, okay? And so that narrows it down. We have 1 negative and 2 positive. So just by glancing, all right, it has to be even, so it's not going to be A, it's not going to be C. It has to be B or D. Again, it's positive, so we're going up, and we can double check our intercept. So -1, 0, 1, and 6. Okay, number 8 is very, very similar. You can put it in the calculator, or you can analyze it. This time it's even and it's going down. So that means our ends are going to be like this, and that narrows it down for you pretty quickly. Okay, now number 9 is a little bit different. It says find the zeros of the polynomial function and state the multiplicity of each. So first we find the zeros. So the opposite of this is -4. The opposite of this one is 5. Okay. The smaller 0 has a multiplicity of what? This gives me the smallest 0 because it's -4, and its multiplicity is 2. This gives me the 0 of 5, so that's the larger, and it has a multiplicity of 1. So this one's repeated twice. This one is repeated once. Okay, sorry about that transition. Had to take a little pause there. All right, so moving on to number 10, we're going to find the zeros of the polynomial function. So that -3, we don't worry about that. So we just need our zeros from the other. So this is -1, -1, -1, and +3. So the zeros are just -1 and +3. Okay. The smallest 0 is -1. It has a multiplicity of 3. The larger one has a multiplicity of 1. Okay. Now, 11, 12, and 13, we are going to switch over to the Desmos calculator. So let me go there. All right. So our first one is x cubed. X cubed minus 7x minus 5. Okay, so we're looking for zeros. So there they are. Okay, you can click on them and they pop up. And Math Excel says round to 3 decimal places. All right, so this one would be negative 2.166. This one's negative 0.783, and then 2.949. All right, and I think all of them in Math Excel today say round to 3 decimal places. So that's all you're going to do for 11, 12, and 13. You're just going to type it into the Desmos calculator, find those zeros, and type those numbers in, separated by commas. Okay, so those should be super, super easy. Because we've been doing this, we've been graphing things in the Desmos calculator and looking at them and finding those zeros. So hopefully those won't be a problem. All right. Now, switching back, you have 3 more problems. So 14, 15, and 16 are all set up very similar. So you're given a scatter plot, and you have to decide if it's quadratic, linear, or polynomial, meaning it's not linear or quadratic. So we need to talk about what linear and quadratic are. So linear is a line. Okay. Quadratic is a U shape, and it goes up if A is greater than 0, and it goes down if A is less than 0. Okay. So if you look at this shape, is it a line or a U shape? Okay. It's a U shape. Does it go up or down? It goes up. So A is greater than 0. So your option is A there. Okay. 15 and 16 are very similar. You're going to decide if it's linear or quadratic. And if it's quadratic, is A greater than 0 or less than 0? So positive or negative. I don't think that any of them are going to be polynomials, but if you had a graph like this, that would be polynomial, or something like that, that would be polynomial. But I think that all of them today are either linear or quadratic. Okay, so there are 16 problems in your Math Excel. I've walked you through most of them. The ones that I didn't are very, very similar to ones that I did work out, so that should be helpful to you. Again, you can watch this video, do side by side with your Math Excel if you want to. Whatever works best for you will work for me. And if you need any help, I'm here. I would be happy to assist you with whatever you need, any questions or whatever. You can always jump back in the Google Meet, send me an email, hit Ask My Instructor, whatever you want to do. But just let me know if you need me. Have a great rest of your day.